I'm looking at a Toyota Technical Service Bulletin right now, document number TC24-0W-20EN. And in the third paragraph of the field findings section, there's a phrase that should have been front page news for every Toyota owner running 0W-20 oil. Instead, it was filed quietly, distributed to dealerships, and largely never made it to the people who needed it most. This bulletin addresses something that mechanics have been arguing about for years. And the reason it matters is because 0W-20 is the most widely specified motor oil in Toyota's current lineup. Camrys, RAV4s, Corollas, Highlanders, millions of vehicles on the road right now are running it. So if there's a documented scenario where 0W-20 can accelerate engine, you need to understand exactly what that scenario looks like. That's what we're going to work through today, start to finish. Here's the thing. Toyota didn't specify 0W-20 because they were cutting corners. That framing is too simple, and it's not fair to the engineers who developed it. The move toward thinner oils across the industry has been deliberate, multi-year, and primarily driven by two forces: fuel economy standards and cold start wear reduction. Both of those are real engineering priorities, and both of them are genuinely served by lower viscosity oil. Let's start with why 0W-20 actually makes sense before we look at where the problems surface. That 0W prefix refers to the oil's cold temperature flow behavior. In SAE, viscosity grading, the number before the W tells you how the oil performs in winter conditions, specifically how quickly it flows when your engine is cold. A 0W oil flows faster than a 5W, which flows faster than a 10W. Think of it like the difference between water and light syrup being poured on a cold morning. The water moves instantly. The syrup needs a moment to get going. Now, why does that matter? Because the first 30 seconds after you turn the key are the most mechanically punishing moment of every drive. The oil hasn't fully circulated. The pump is pushing cold, viscous fluid through passages that are still contracting from overnight temperatures. Metal surfaces that normally ride on a continuous oil film are temporarily running dry or near dry against each other. That's where a significant portion of long-term engine wear actually accumulates. Not on the highway, not at operating temperature, but in that narrow window between cold start and full pressure buildup. 0W-20 was engineered to close that window, and the data on cold start protection for 0W-20 versus heavier conventional oils is strong. Toyota's own internal documentation, along with third-party engine analysis, consistently shows that 0W-20 reaches critical engine components faster at cold temperatures than its predecessors. That's a real benefit, full stop. And on fuel economy, thinner oil creates less internal friction. Less friction means the engine doesn't have to work as hard to move its own parts. That translates directly to MPG numbers. The EPA's test cycles reward that. Automakers who hit more aggressive fuel economy targets use thinner oil as one of several tools to get there. This isn't a conspiracy, it's physics. So Toyota's position was rational, well-reasoned, supported by testing. But pay attention to this next part, because this is where the bulletin becomes significant. The scenario Toyota's service bulletin identifies is one that wasn't fully accounted for in the original specification modeling, or at least wasn't communicated clearly enough to owners. The issue is what happens to 0W-20 under high thermal load, particularly in naturally aspirated engines doing a specific type of driving pattern. Most engine oil specifications are modeled against what engineers call normalized duty cycles. That's a blend of cold starts, city driving, highway cruising, and occasional hard acceleration. The kind of driving that represents statistically average use. But real-world driving doesn't always look like that. And when it doesn't, thin oils can behave differently than their specifications suggest. Here's the core issue. At operating temperature, motor oil relies on its viscosity to maintain what's called a hydrodynamic film. That film is the microscopic layer of oil between moving metal surfaces, between the crankshaft journal and the bearing, between the piston rings and the cylinder wall, between the camshaft lobe and the follower. As long as that film is intact, the metal parts never actually touch each other. They ride on oil. The moment that film gets thin enough to rupture, you get metal contact. You get wear. Kinematic viscosity at high temperature is the relevant number here. 0W-20, by definition, has a lower high temperature viscosity than 0W-30 or 5W-30. That's part of how it achieves its efficiency benefits. But lower viscosity means a thinner film. And film thickness has limits. Think of it like this. Imagine trying to keep a playing card floating between two moving magnets with a squirt of water versus a squirt of motor oil. The water film breaks almost immediately under any lateral pressure. The oil film holds longer because it has more body to it. 0W-20 is closer to the water end of that spectrum than 5W-30 is. Now, in the normalized duty cycle that Toyota's specification was designed around, this is fine. The oil is doing exactly what it should. The film holds. Wear rates stay within acceptable bounds. No problem. The bulletin identifies the problem zone as sustained high RPM operation. In elevated ambient temperatures, particularly in engines that have accumulated significant mileage and where oil change intervals have been pushed toward the upper end of Toyota's recommendation. All three of those factors together, high RPM, hot climate, extended interval, appear in the bulletin as a combination that may increase the rate of oil film breakdown compared to what the standard spec anticipates. Wait until you hear what the technician documentation actually says about the symptom pattern. The field reports referenced in the bulletin describe a specific wear signature that showed up in teardowns of high mileage 2.5 liter and 2.0 liter dynamic force engines, the family that powers the current RAV4, Camry, and Corolla. The wear wasn't catastrophic. It wasn't the kind of sudden engine failure that triggers recalls. It was gradual, subtle, the kind that doesn't show up as a noise or a warning light until the engine is already measurably past its intended service life. The wear pattern concentrated on two areas: upper cylinder walls and camshaft bearing journals. Both of those locations are consistent with what happens when oil film becomes inconsistent under load. Not complete film failure, but film thinning that allows occasional metal contact. Over tens of thousands of miles, occasional contact becomes cumulative wear. The sound signature, according to some technicians who have seen this pattern, is a faint ticking at high RPMs that settles back down at idle. Not the dramatic rod knock or lifter rattle that most people associate with engine trouble. Just a quiet, intermittent, metallic click under load. Easy to dismiss as normal. Easy to attribute to heat expansion or fuel injector noise. That's the insidious part. Most people don't know this, but wear that accumulates silently over time in these specific locations can affect compression consistency across cylinders. When cylinder wall wear is uneven, and it tends to be uneven because not all cylinders see identical thermal loading, you can get subtle compression variance that shows up as slightly rough idle at cold start, marginal power delivery, or fuel trim corrections that push the engine management system to work harder than it should. None of these are dramatic. None of them individually trigger a diagnostic code. But collectively, they represent measurable degradation in engine health that, under a different oil specification or tighter change interval, may not have developed. The bulletin doesn't say that 0W-20 caused this damage categorically. The language is careful and measured, as it should be. What it says is that under the identified conditions, the evidence from field cases suggests that 0W-20's viscosity profile may be a contributing factor, and that certain operators may benefit from a modified approach. That distinction matters. A TSB is not a recall. It's not an admission of defect. It's Toyota's engineering organization communicating to its service network that a pattern has emerged in the field worth paying attention to. And that's not even the worst part of how this information is circulated, or more accurately, failed to circulate. TSBs are distributed to authorized dealerships. They sit in database systems that service technicians can access when diagnosing a specific complaint. But here's the chain of custody problem. A bulletin like this doesn't automatically trigger owner notification. It doesn't generate a mailer. It doesn't pop up on your dashboard. If you walk into a dealership for a routine oil change and you don't specifically ask about active TSBs for your vehicle, there's no process requirement that the service advisor volunteers this information unprompted. Some do, many don't. That's not an indictment of every service department. It's a structural gap in how TSB information flows from manufacturer to consumer. The result is that an owner running a 2022 RAV4 with a 2.5 dynamic force engine, doing highway commutes in Arizona with oil changed every 7,500 miles, may be operating in exactly the usage profile the bulletin flags, and have no idea this document exists. Let that sink in for a second. Now, let's talk about what actually changes in practice if you take this bulletin seriously. Toyota's standard 0W-20 recommendation isn't going away, and for the majority of owners in moderate climates doing mixed driving with timely oil changes, the original spec likely continues to perform as designed. The bulletin doesn't suggest that everyone should immediately switch to heavier oil. That's an important point. The modification recommendations are conditional. Here's how to read the if-then logic on this. If you're driving in a consistently hot climate, consistent ambient temperatures above 90 degrees Fahrenheit for significant portions of the year, and your engine has more than 75,000 miles and you're regularly driving at highway speeds or above for extended periods, the bulletin's evidence suggests that shortening your oil change interval below Toyota's standard recommendation may be worth discussing with your mechanic, not necessarily changing the oil spec itself, but reducing the interval. The reasoning is straightforward. As oil ages in use, it loses its viscosity improvers, the additive components that help it maintain its rated high temperature viscosity under shear stress. Fresh 0W-20 performs closer to its specification than 0W-20 that has been in service for 6,000 or 7,000 miles in a hot engine. Shortening the interval keeps the oil's performance characteristics closer to their intended values. If you're operating a turbocharged variant, and Toyota's lineup increasingly includes turbo 4-cylinders, in certain markets, the thermal load on the oil is substantially higher than on a naturally aspirated engine. Turbochargers run at temperatures that can exceed 2,000 degrees at the turbine, and the oil that lubricates the turbo bearing gets exposed to those temperatures repeatedly. Thinner oil is more vulnerable to thermal breakdown in that environment. If you have a turbocharged Toyota and you're in a warm climate, a conversation with a mechanic about whether 0W-20 or 5W-30 remains within Toyota's published approved viscosity range for your specific engine is a legitimate question to ask, not a panic move. Just a conversation grounded in the actual data. If you have a naturally aspirated engine doing mostly urban stop-and-go driving, in a moderate climate with changes at 5,000 miles or fewer, you're probably in the clear with the standard 0W-20 recommendation. The bulletin's concern areas don't strongly apply to that profile. This next part is going to make you want to check your own car this weekend because the physical inspection tells you more than the service history log. Pull your oil dipstick, not just to check the level, but to actually look at the oil itself. Fresh 0W-20 is almost transparent amber. You can hold the dipstick up to light and see through the film. Oil that has been in service for several thousand miles. In a hot running engine, starts to darken toward brown, then toward black. That darkening is normal oxidation and combustion byproduct accumulation. It doesn't mean the oil has failed catastrophically, but if your oil is dark brown or black before it's due for a change, that's a physical indicator that the thermal environment in your engine may be harder on oil than the standard interval assumes. Smell the oil on the dipstick? Yes, actually smell it. Clean motor oil has a mild petroleum odor, slightly sharp, not unpleasant. Oil that has experienced significant thermal stress develops a distinctly acrid, almost burnt quality. If your oil smells burned well before its change interval, that's a sensory indicator worth acting on. Change it early, don't wait. While you're at it, if you have any access to your air filter housing, check the inside of the crankcase breather hose. On engines where oil consumption or oil film degradation is occurring, you'll sometimes see a gummy, brownish residue on the inside walls of that hose. Clean inside surfaces suggest normal operation. A thick, sticky deposit suggests the engine's oil is seeing more stress than ideal. These aren't alarming findings in isolation, they're just data points. But data points are what separate informed maintenance from reactive repairs. There's a broader principle buried in this bulletin that applies beyond Toyota, and it's worth naming directly. The industry-wide shift toward thinner oils over the past 15 years has delivered real, measurable benefits in fuel economy and cold start protection. Those benefits are genuine, but the engineering specifications that govern these oils are developed against usage models that may not perfectly represent how every owner uses every vehicle in every climate and duty cycle. The implicit assumption behind most oil specifications is that owners will follow recommended change intervals, that their driving falls within a certain statistical range, and that their climate doesn't represent an extreme outlier. When any of those assumptions breaks down, the margin between the specification's design intent and the actual operating conditions narrows. TSBs like this one are the system working as it's supposed to. Engineers reviewing field data, identifying where real-world conditions are diverging from modeled conditions, and updating guidance accordingly. The problem isn't that Toyota issued this bulletin. The problem is that most owners will never read it. You can search for Toyota Technical Service Bulletins using your vehicle's VIN number. The National Highway Traffic Safety Administration's database at nhtsa.gov maintains records of TSBs that have been submitted, and you can search by make, model, and year. It's not always perfectly comprehensive, but it's a legitimate starting point. A Toyota dealership service department can also run your VIN and show you any open or recently issued TSBs relevant to your specific vehicle. If this bulletin applies to you, the action items aren't complicated. Shorten your oil change interval if you're in a high demand usage profile. Use oil that meets or exceeds Toyota's WS or ILSAC GF6 specification. Don't just grab whatever's cheapest at the parts store. And if you're in a consistently hot climate with a higher mileage engine, ask your mechanic specifically whether your engine and driving conditions put you in the scenario this bulletin identifies. These are small adjustments. None of them are expensive. The cost of shortening an oil change interval by a couple thousand miles is genuinely trivial compared to the cost of addressing cylinder wall wear or bearing journal damage that's been accumulating quietly for years. That's the math that this bulletin is really asking you to do. And if you know someone who drives one of the vehicles in Toyota's current lineup, especially in a warmer region or with higher mileage, send them this. Not because there's reason to panic, but because this is exactly the kind of information that should be traveling by word of mouth instead of sitting in a dealership database waiting to be found. If this gave you a clearer picture of what's actually in that bulletin, and what it means for how you maintain your engine, Leave a comment below with what you're running, right? Now, the oil spec, the interval, and your climate. I'm genuinely curious about the range of real-world conditions out there. And subscribe so you catch the follow-up, because we're going to go deeper on how to read a UOA, used oil analysis, and what those reports actually reveal about engine health in ways a dipstick check never could.